What we're going to do in this video is we're going to talk about the difference between a pure substance and a mixture. And it's easy to start with a pure substance because pure basically means same. So we need to find an area or a container that has only the same substances. That would be a pure substance, whereas a mixture would be many different types of substances in that same container. So here we would have, just imagine we have 4 containers, A, B, C, D, and our task would be to find which one's a pure substance and which one's a mixture. So we start the first one, A. Here we have chlorine. So each of these purple dots is meant to be a chlorine atom, right? So in this case, we have a pure substance because we have only chlorine. So that would be pure substance. They're all the same. Every one of these would be the same, and so we have a pure substance. Next one, in container B, again, even though we have 2 of them bonded together, so in this case, what this is oxygen gas, so O2, which is oxygen gas. There's still, each of them, if we count them, or look at them, they're all still the same. So we have only these double yellow molecules, which are oxygen gas. In this case, it's still a pure substance, because in this container, we only find things that are the same. Now, the next one, you might think this might be a mixture because it looks like there are different types of things found in this container. But if we look at it, each of these things have the same kind of atoms. In this case, this is H2O. So we have 2 hydrogens and 1 oxygen. So in this case, one of these is a water molecule. H2O is water. But if you look at the container, we only have water molecules. So 1, 2, 3, 4, 5. We have 5 water molecules. So even though they have different types of atoms connected together, because it's all the same still, we still would consider this to be a pure substance. Now the next one is going to be where the difference is. So look at D here. If you look at this container, we have, this could be chlorine, right? The purple are chlorine. Remember the yellow were oxygen. And this one here was a water molecule. So we have different types of pure substances in the same container, and that makes it a mixture, right? So D is a mixture because we have different types of substances found in that same container, and that's what a mixture is. In this case, this could be tap water. So tap water is one example of a mixture because we don't only have water, so it's mostly water, right? So mostly H2O, but we also find some other chemicals inside. So for example, we might find chlorine or fluorine or oxygen. So tap water, this water here, that's tap water. The thing that comes out of tap would be an example of a mixture. Whereas distilled water, so distilled water is right over here. Distilled water would be almost only H2O. So remember that would be, it looks similar to what this would look like. So this would be similar to what distilled water. Distilled water is almost a pure substance. There might still be a few other chemicals in there, but because it's almost only H2O, all the same, that would make distilled water a pure substance. Whereas salt water will have lots of H2O because it will have a lot of water molecules, but because it also has the word salt in it, salt water will also have, for example, NaCl, right? So it has other chemicals in it apart from only water. So salt water would also be a mixture. So from this video, what you need to be able to get out of it is a pure substance is if they're all the same. So any area you look at, if we only find the same substance, that'd be a pure substance. But if we have a mixture of different substances, that would be a mixture. So we say, for example, distilled water is almost only H2O, so we couldn't say that's almost a pure substance, whereas tap water and salt water have water, but they also have other chemicals, chlorine or salt in it, so that would be a mixture.